That's exactly right. Most shows we do like this, people start with the question, what is an agent? But we think of an agent, it's an atomic unit. It is the smallest possible thing you can work with. And for us, that felt like the natural place for that to live would be a microservice.
Hi, my name is Joshua Schoen, and this is WorkAI, where we discuss the intersection between AI and the future of work. Today, I have Ramachandran and Dave Brewster, who are building and transforming the way backend architecture is working with AI. It's great to have you guys here.
Thank you.
Thank you.
Big, big thing that I wanted to get into, and we were starting talking earlier, is what was really the impetus for you to go out and go after this? You both have backgrounds in Silicon Valley. You both have pretty big histories in working and making big companies happen. Why tackle this problem? And what do you know that other people don't?
Yeah, Rob, you want to go first?
Yeah, sure. I mean, for me, it's a very personal thing. It was about great things only happen when great people get together. So I met Dave and Luke, who's a third co-founder, who's not here. And I just felt a special connection from having just been in the same space for a while in the where you're data people, analytics, machine learning, that type of background, and a good complement of both technical and commercial skill sets, right? So that complement and just the interaction personally, that was a big part of wanted to do it with these guys. Why this particular problem? I mean, obviously AI was exploding and is exploding, and certainly we wanted to go tackle something that very intrinsically leveraged LLMs and AI to make a big impact. And so we saw a big opportunity. We'll get into that a little bit. But that was, and timing, right? I think timing makes a big difference too. You can do things early, you can do things at the right time. And we felt like it was a perfect opportunity from a timing perspective to go do something new. And Dave, you want to maybe get into
Yeah,
the
from a personal aspect, really, the next company I was founding, I started the last one with Walla. If you ever have a chance to hear him play guitar, is amazing. And this one, I was really just looking for a drummer. That's all I was looking for. So, no kidding. Robbie plays drums, I play bass, Ninja plays guitar. We wish we could get Ninja, but he's busy doing Vertex. This is my seventh startup, Josh. So, when you've been around the game a little bit and you get older, you don't want to put up with people that you don't get along with. And I don't mean get along with, oh, I hate that person or I can't work with that person. The number one thing is who are you starting it with? Like you're basically getting married. A lot of times within a startup, you're going to spend more time with your founders than you are with your spouses, right? Your significant others. So it's about the people. And so when I met Ravi, we were actually working on a different company before this one with someone else who unfortunately fell ill, but now is doing absolutely fine. When that kind of blew up, we really wanted to work together. And that's the connection that you have to have from a people person point of view when you're founding a company. I think a lot of younger founders will put up with people, if this is their first time, even their second time, will with people that they think they can be successful with. It's like a marriage again. You're not going to be successful with somebody that only has superficial qualities. They got to match what you want. They got to meet what you want. So from a people point of view, we meshed. And then Luke, I had worked before with, he worked with us at Paxata. I have to represent Paxata today. He worked with my last company I founded and worked with us, and Luke is awesome. And I knew Luke, and it was a matter of getting Ravi to know Luke and having them spend the time. So once that was out of the way, it's, the hard work begins, but the hard part is over, if you will. So yeah, so that was from a personal people point of view. That was the beginning of us in the company. And then it's a matter of what are we going to work on? And Robbie, you want to take him through?
Yeah, I mean, we were, as Dave mentioned, working on a problem from a data use case perspective. How do we use LLMs to effectively shorten all the pipeline of data, which is today very slow moving and takes weeks and months, perhaps, to get data in a useful shape that can be consumed by. And in working on that issue, we really came down to the realization that you needed to break these problems down into much more simple, smaller chunks, i.e. agents, have them do specialized things and bring things together. And that was when we looked at what was out there to do that, there was not much out there in the market. And so we decided that building something for ourselves for that particular use case was difficult, but we went about doing that. Then we really saw a big opportunity as we started talking to more people that this was something that was sorely needed from a more of a broader application lens. And for anyone building apps on Gen AI, needed ways to make it simpler, easier, abstractions, modular ways to be able to build and put these things together, because that was just an inherent challenge. So that's the genesis of the problem that we face ourselves. Hence, we ended up building a toolkit for a use case and then saw a much broader application for it.
Yeah, I mean, this is a really interesting. Reading through your website, it's a big thing that I got from one of your guides. It said, in reality, LLMs are dumb. Mistakes. They don't do everything right. And so you have to orchestrate and build basically what I think of more like microservices with these quote unquote agents to attack the problem. And I was curious how you went about deciding to do this and also being able to think about the problem in itself and making it work.
Yeah, I mean, it started from the data example that Ravi was talking about. When we first started trying to work on, so what we were really doing was trying to have an agent to start with, an agent, like everybody else starts originally, be an expert in data for a particular area. So say I'm going to take, I don't know, user profiles of the people, customer profiles, people I sell to. And I want an agent, an expert in that, in those people. What we quickly found out, I think as most people do, is the amount of data you need to augment an agent with to answer those questions. If you're asking more than than one contextual layer of question, the agent gets lost very easily, or the LLM gets lost very easily. And what we found that worked very well is if we had an agent focus on one particular thing, that then another agent talked to get the answer for that thing, and then rinse and repeat and multiply, we found that we got way more accurate answers. And I think I can give a kind of agentic RAG that people are messing with now, right? And then hierarchical agentic RAG. If you break down the problem into surfaces that are single context or one thought at a time or one area at a time, and you don't confuse the LLM with lots of extraneous information, you get a very accurate answer. And I think people are finding in that technique that works very well. And you can apply that to a lot of cases. So what we saw about a year ago, it was almost exactly a year ago, to be quite honest. Heck, that works way better. And there's nothing out there that does it. Not only is there nothing out there that does it, but don't just take that into account, but none of the frameworks were, and I would claim very few are currently on an enterprise version of that, right? With security, trust built in, monitoring, metering, things like that. And in a way that could be deployed in an enterprise that people in the enterprise are happy with deploying. No one was working on that. So we saw a huge opportunity. We had a big opportunity that we were working on. We saw a much larger opportunity to work here. It brings me back to my past, way back. My second or third real job was a company called NetDynamics, which was the first app server company. We take app servers for granted. There was a first, it was NetDynamics. That was a wide open space, very similar to this, where the opportunity to do verticals on the web in 96, which is when we started when they started that company. I wish I started that company. In 96 was kind of a thought, a few apps at the time, not a lot, a few. But the bigger opportunity was the plumbing behind it, the server behind it, the API behind it, the SDK behind it. And this very much reminded me time-wise and technology-wise, or problem-wise and technology-wise at that time. So those two reasons, again, are why I personally jumped into it and what that opportunity is and why it's huge. It's a very large opportunity.
I guess the thing that when I started seeing your application is it reminds me a lot more of Docker or Kubernetes or containerized applications where you're breaking down pieces of jobs into a microservice. And that way you can isolate the variables for what's going on. But instead of having deterministic code within it, you're having the probabilistic agent consuming a single action.
That's exactly right. That's a nutshell. We think of agents. People ask that question all the time. Most shows we do like this, people start with the question, what is an agent? But we think of an agent as that exactly what you just, it's an atomic unit. It is the smallest possible thing you can work with. And for us, that felt like the natural place for that to live would be a microservice, just like you said. That's exactly right. It doesn't mean it needs to run in its own container. It doesn't mean it needs to have the same thoughts applied to it as a code container, but it does feel that way. And the second thing we saw very high correlation with is what we were working on is more like an operating system than it is anything else. So you're dead on when it said it feels like Kubernetes. To us, when we're coding it, it feels like we're coding an operating system for autonomous services, probabilistic services that run inside of a back. That's Kubernetes or ECS or whatever you want to run it in.
Yeah, and I think the other thing is just right on that is that we wanted to, in some ways, minimize as much as possible new things in an enterprise that people have to go learn.
Mm-hmm.
And so if you think about containers and Kubernetes and things like that, those are concepts and technologies that people are well versed in. And at least that part of it could be reduced as opposed to let's go find another way for you to go deploy these things, right? So that was also one of the key benefits of doing what we're doing.
No, and this is what I was curious about is you're growing at a pretty fast clip. What is it? It's 1,800 downloads per month and growing.
Yeah, maybe more now.
Yeah. So where are you seeing, I guess, in the more business use cases where you're starting to charge money or for your service? Is it that it is the SaaS application that is building it up, or is it the enterprise themselves that's building a bunch of tools together and then building the workflow?
Yeah, Ravi, do you want to take that?
Yeah. So first of all, we're not charging money today because it's an open source project. So for us, it's about awareness and adoption. A lot of enterprises are in different phases of adopting AI. Agents is new. There's a lot of obviously hype around it, but it's still early days. And so what's important for us is that users using developers, engineers are developing their applications using our framework and deploying it in real production use cases as opposed to simply doing POCs. Now, POCs and pilots are great, obviously show the art of the possible, but we really focus on production use cases, right? And just a good example is one where Dave certainly spent a bunch of time in the insurance business. I have been not as long as he has. And Dave, maybe you can walk through that one example, because that's the claims example is maybe
Yeah.
business oriented as well.
Yeah. So when the insurance world, so I was at Guidewire Software for a lot of years. I founded the platform team and worked with some amazing people at that company. That was some of the smartest engineers I worked with. The thing in insurance, as much as like companies like Guidewire, and there's a few now that try to make them be structured so that you can solve the problems in structured ways, right? So everything that people do with insurance is largely unstructured. If I go file a claim, sure, the claim agent's going to fill out a form, but a lot of the place they fill out are in notes because I wreck my car. Yeah, it's this quarter panel, it's that quarter panel, but what happened? Right. And that what happened is where an adjuster, or more importantly, somebody from litigation is going to step in and look at that claim and say, is this a real claim? Should we pay it out for the adjuster? Let's talk about litigation. Or is this a fraudulent claim? Right. And to make that determination, the way that every insurance company works today and has for a very long period of time is they try to automate the easy ones up front and try to catch the anomalies and then send the anomalies to a human. Still works that way. Maybe some machines got better at detecting the filter at the beginning, but that's a perfect example for a series of agents, and especially agents that can learn over time for what this company is, for what the type of claims are that's typically fraudulent. and the patterns associated with those. We talk about training a model to do that. Well, there's no reason you can't have an LLM with in-context learning, and you use the information that you're learning in context, save that over time and create a model over that helps guide and detect what's going on. So what you're really talking about there is creating memory for an LLM, say it's simple chatbot. Let's just keep it easy. And then using a traditional AI model or a machine learning model of that data to then predict what's going on, right? Very cool way to do it. Very cool way to think about it. And it's melding kind of the way an insurance company internally works today with agents and LLMs that gives them much, much more accurate responses, right? You don't have to hard map the signals for that model. You can let an LLM do that and do inference based on that. So pretty cool, non-traditional way of thinking about it.
Well, let's dig into that particular use case. If I were just saying mapping between the different agents and steps between it, what would be the different pieces of the container or the questions that you would be using to build out that workflow?
Yeah, exactly. So you have an agent that looks at the notes of the claims coming in, right? And let's make it simple, Josh, because the real use case is hideously complex with pipelines and stuff like that. But let's just keep it simple. You have it's looking at the information in the claim, not just the notes, all the information, but as well as the notes. And you're asking the LLM, given a set of guidelines, to determine, is this likely fraudulent or not? Now, how do you do that? How do you break that down? Right. So one way to do that is to have the LLM map everything that's there into a CSV, if you will, or a row in a CS, so that it can be used inference in a classical model. That's one technique. That's what I was talking about. The other technique is you can give it in a series of prompts to multi-shot and to determine if that thing is likely fraudulent or not. Again, we're not determining if it's fraudulent. It's should a human look at this or should they? So it's like a nice bloom filter. And so the series of prompts that you that you give to that need to change and grow over time as the model learns what is fraudulent and what is not fraudulent. So what you typically do is you record the memories of what came, you have it make a decision, and then you have the determine the characteristics of the claim that it thought that it was fraudulent or not. What caused that? You store that as a memory, and you do that in times over times, and then you have a background process that comes through and processes all of that external memory and uses that to then go rewrite the examples and rewrite the prompts of what's right or wrong. Now, in this particular case, there is human intervention in to determine right and wrong and what is good and what is bad. So you would also need to give reinforcement feedback from the humans that if something kicked up that wasn't fraudulent, they particularly have somebody that goes in and amends the records that says this was not fraudulent. These are the reasons why, and you're in the reasoning, and that is also taken into account. And then the background process, like I said, rewrites the system prompt and rewrites the examples going in so that it can make better judgments going forward. It does lead to a large context of the thing being processed. It's way crazy accurate, right?
What I love about this use case,
Hierarchy, et cetera, et cetera, et cetera.
yeah, what I love is that there's a human in the loop in this use case. And I think in general, I would say there's a range of when people talk about agents and everyone assumes it's the ultimate autonomous everything. You just point something and you're done. But the reality is where we are today is you want humans in the loop, and there's a range of autonomy in these use cases, specifically in these transactional type things where there's meaningful outcomes from the result that you're trying to drive. You want a human in the loop today, and over time that'll get better. And I think we'll have less reliance on humans in the loop. That we don't want to have to, but it's really something that what we see in enterprises today that is very important. That's definitely a part of these use cases. So yeah, it's a good example, I thought.
You know what I find interesting, and I think you're probably even better to speak about it than I am, is LLMs, because of their nature, in that they are associating what is the next word in their
Right.
process. If you train it specifically to do one piece of the task, it makes it so that it actually performs worse on any other tasks that it's asked to do outside of that context
That's
frame.
right. Yeah.
And so, from that perspective, it means that you can't use an LLM to have artificial general intelligence, but you can have it be very smart at doing one job.
Reasoning, choosing best in all kinds of tasks like that. It's, you almost want to give some LLMs, you almost want to give a lobotomy to, so it forgets the specific data, but has an impression of what should come next.
Well,
That's what you really want, so that it doesn't answer with its general knowledge, because you gave it specific factual knowledge, not just hallucinated stuff, right?
I think that's also where probably the small language models and pruning on the nodes when they're actually creating the models
Right.
that go in is coming
right.
into the process.
Yeah, the new I call them compression techniques. There are much better words, but where you train a smaller LLM from a larger LLM and give it generalized conceptual knowledge instead of specific technical knowledge is like Sonnet 3.5
Yeah.
is amazing. Absolutely amazing. Sonnet 3.5 is really amazing to work with, I think. I really enjoy it.
But yeah, I guess from my perch is you start seeing people in the California state legislature getting
Right.
really concerned about people creating dirty bombs or the machines taking over. And I don't know if that's actually the case.
Well, they
I
just
don't
want to
think
be
it's,
like they just want to be like the EU. So that's a different problem.
that's a, California just wants to be like, that's exactly right. But I don't think the EU's going to go that far. But you notice that bill got severely watered down towards the end. And by the time it actually, I don't know if this version gets signed. I sure hope it doesn't. But I think the thing that will eventually be there will be, I don't know. I don't know. Anyways, but you're right. Like, legislating who can own the large model is like shooting yourself in the foot. Like, that's a pretty dangerous position.
But I guess in some ways, it's this layman's perception of the world about what a model is and what it's doing
Right.
versus what you're doing, which is enabling the orchestration of models which work in this probabilistic way to be trained up to do very well, good at a specific task,
Yeah.
and then working together in tandem in an architecture designed by a person that has to reason through it.
Yeah. We're using LLMs as a reasoning engine is the end of it. And we're not retraining the LLM, right? We're doing either classical machine learning or not, just giving it the right information to make the likely choice with very specific information, right? Instead of generalized. We're not asking it, how does my ice maker work, right? We're asking something very specific. Is this claim fraudulent? That's not a thing it's going to have generalized knowledge on, right? It can't.
Or or the patterns in the words that it's saying about the case worthy of further investigation?
Right. Exactly. That's right. That's right. That's right. So yeah, it's an interesting time, right? Again, I bring this back to the app server days and when Net Dynamics was formed in 96. What we have available to us to app tools on the web is pretty advanced. We're in 1996 from an app server point of view. What will this be like in 5 years? What will the tools be there to help you create apps? It's a super exciting time to be working on these things. It really is. So anyways,
They'll tell me a bit more about what in 5 years from now and where you will fit into the world that
yeah,
people are using with these agents.
it's a really hard question because the time periods are so compressed right now, and who knows the next great architecture after transformer that will come. But just given the knowledge today, if you look at what the general people have, general enterprise architect has to about what LLMs are and what they can do with them. It's not much more than a simple co-pilot. It's not much more than here's a bunch of docs, let me search them better, right? That's where the enterprise is today. But and a lot of that's the tooling. The reason for that is the tooling is not yet mature around the art of the possible. If you take a step back and you look at, there's a few toolkits like Eidolon out there, but if you take a step back and you look at Eidolon, we'll just talk about ours. The goal of Eidolon is there's two parts. There's the server part. We'll talk about that, I guess, in a little bit. But the SDK, the goal of the SDK is to modularize the problem in a way somebody can think about one thing and one thing only, whether that's their business logic or they're coding Eidolon themselves and they need to think about how this particular LM connects in or whatever. But some of the things that we're adding that make like fundamental first principle things that we're adding that I think that will bring a lot to the world. We're adding memory to Eidolon. Now, we didn't in context learning, we didn't invent adding memory to an LLM, right? A lot of people have been working on that. The MemGPT guys and then MemZero most recently, and lots of papers. But applying that in a way that's a generalizable tool for agents is something we likely will be the first at. And it's really weird and exciting working with it. So I'll give you an example. We have an agent that you can reuse very easily that talks to other APIs. And I'm personally working on a project right now that is GitHub, and it's putting an interface on GitHub so that developers can use it for open source projects as our target to be more productive. I'll write my pull request description for me. When a pull request when I open a pull request and I forget to link it to an issue, I link it to an issue or create the issue for me, on and on and on. Stuff, not important. But the cool thing is when you're talking to GitHub's API, we have an API that you downloads the JSON schema, the open API JSON schema for that, and can autonomously call all the methods in GitHub. And when you add memory to that and you say, I have an agent, go and look for the issues associated with this pull request. And you add agentic memory, not user memory, agentic memory, meaning that agent learns. It learns, it's got tons of API calls it can call. And say there's 6 related to issues. There's more, say there's 6. It learns pretty quickly, a couple turns, that this is what I should call, and I should call it in this way. And so what that does is that reduces error. It's just, if you think about it, really? And it shocked me. I just tried it out yesterday. It shocked me when I did it. Like the things it chooses to remember, if you have an agent and that agent's job is to call the GitHub API and you give it memory, which means it autonomously writes down the memories that it thinks are important. You give it a prompt, it does it. It learns quickly when you ask questions about linking a PR to an issue that it calls the right API to search the issues to see if there's something there. I wouldn't have guessed that, but it did. Now, blow that up to an enterprise, right? I'm an enterprise. I'm doing enterprise data stuff. I have a bunch of different systems that I could call. Somebody asked me a question, I fumble through the answer 3 or 4 times with the user. No, that wasn't right. That didn't work. Try again, try again, try again. It gets it right. The user says, oh, that's right. It remembers that and it learns that. So you can have 100 systems that have similar data, and through user interaction, the agent that calls the APIs are going to learn what APIs to call when specific questions are asked. That's mind blowing. As a developer who would have to code that by hand using standard code, that's absolutely mind blowing. So how is that going to change the world in enterprise computing? Ways that people don't imagine. So you go from today, chat with your docs, to you add one thing, memory, and the ability to call APIs. I guess that's 2 things that people aren't used to. That suddenly opens up your mind as a developer to think, wow, that not only is it an easier way to call APIs, but it might be better, like, than writing this code, having thousands of lines of test code for all these different APIs, blah, 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 blah. Suddenly you're down to, how do I code again? Right? What do I do? How do I think about these problems? It changes a lot quickly.
What does that mean for the databases and how people will be
I,
structuring
I
ways
don't
that agents?
I don't know. That's a great question. I don't know. If you think about Salesforce, and I could search Salesforce, say they put out, they're working on the ability to chat with your Salesforce info. Me as an agent framework, all I have to do is integrate with that. And that's trivial. Like what's the interface? Text. That's it. Human text. So to have a human call that or an agent call that doesn't matter. So if I want to then start chatting with that data, as long as they provide a description of what is available and what's there so that an autonomous agent can read that and, yeah, it should go over, or somebody provides it. That's Salesforce or whatever. That that's great. So now what is a database? It's more like a data warehouse. It's more like these pockets of data that exist. So then I don't know, they add that to Postgres, which they're already working on. And you have the ability to search your Postgres data textually. It's just part of built in. Then do you need SQL anymore? Probably not, right? It's just all about the engine that translates there. So I don't know what that means. I don't know. I honestly can imagine and dream, but it'll be cool to see how it plays out, right? Be really neat.
And so now, like getting into the product and how it's being deployed, love to have you walk me through it and the advantages for using your framework.
Yeah.
I mean, we talked about it before, but let's get into the details here.
Yeah. So if you think about what we do and what we are, there are two parts. There's the agent server and the SDK. And I like to think of this like Unix, like Linux, right? Like Kubernetes, like you said. The agent server is there to provide a operating system so that agents can talk to each other, that agents have a place to store memories, that's similarity memories, file-based memories, or we call them semantic memories, but like key value store, document store type memory places. The operating system provides that for you. So it provides memory, provides communication, networking in a very easy way. And it provides you this, we call it agent processing unit that allows you to talk to a smart LLM, or it's not even to be the heart of the agent so that you can go out and make these calls to LLMs and it provides memory, long-term memory, short-term memory, all these features and functions that you, when you think about APUs at a high level, wrapped up in a way that's easy to deploy in the enterprise, whether that's Kubernetes. So we have a built-in Kubernetes operator so that all you do is kube apply your Eidolon resources. That's a machine, which is like a virtual machine, or agents individually. The machine defines the operating system parameters like the memory and networking name and things like that. And those just get translated into service calls in Kubernetes. So whether it's Kubernetes, which enterprises are very familiar with, or as an individually wrapped single container that you deploy on your own, Eidolon, the agent server provides all of that for you. And in the open source project, we have the ability, open telemetry, for you to hook in any monitoring system you want. Security is also in the operating system. So you can register an RBAC security handler for the agents. You can register authentication handlers. We've implemented and an AD out of the box, or a few other things at the OS level. The open source toolkit has plugins to do that. And it will run agents, like I said, in agents and keep track of the names of the agents. And I'll, in the Kubernetes version, inter-machine communication, because the DNS is built into the environment. If you're doing an ECS, you're going to have to manage that yourself using 53 or whatever, or however you want to. But it gives you a way to do that. So that's the server part. When we will accompany around this. You can imagine some of the things that we'll do around that to make it better. Trust being one of those. Have a higher level of built-in trust, and lots of other features like that. We don't really need to go into that. And then on the SDK side, it's a pluggable framework that allows you to build agents as services. You have an interface to the API. Everything has an interface. Every implementation can be swapped out, which is a thing people love. So if you're using Pinecone, we ship with Chroma out of the box. If you're using Pinecone, you switch out the similarity store at the operating system level, and you have Pinecone. None of your code changes. Nothing changes. It's a configuration change. Or if you want to switch to Claude Sonnet 3.5, the APU for that versus the APU for Llama 3 using a Llama, again, it's a configuration change. It's just a different interface, a different implementation of an interface. The SDK provides that for you. And then the package in general provides quite a few agents that really make most applications, like a RAG agent, an API agent, text to SQL agent, like a lot of the building blocks people would need at a higher level to generate really cool applications. And you likely won't need any code to do any of that, right? That's all just prompt engineering and dynamic development using those built-in agents. Yeah, that's Eidolon in a nutshell. Ravi, I'm sure you want to add something.
Yeah, more just to summarize, and one of the things maybe we didn't touch on very much is the agent server itself is one that really embraces other agents as well.
Right.
So yes, you could use, and we would love for people to use our SDK to build these agents. But, Josh, one of the things we really focuses on the productionalization and the deployment of these agents in the enterprise. And so we want to make sure that it's not just our framework, but if you build agents with other frameworks, could be LangChain or anyone else, we can allow you to very quickly deploy them on with our agent server. So that's just a way for us to embrace the ecosystem again and be open as a company as we are. And that's how we started the company. Let's build in the open, let's embrace other agents and offer these to enterprises in a way that they want to be able to consume and deploy them.
Have you started to see that people are building components on your framework on their own and for the open source community? And so that way, if I build on Eidolon, this particular piece of the pie, you can just plug it in, reuse it, and set up the next step.
So we originally thought there would be a lot more than that, Josh, than happened. We really did, because we built very little in the beginning and hoped that would happen. Maybe it was open prayer, but we did think more would happen. But we do have some. We definitely do have some. Somebody built the OLAM for us. It's not in yet, Google, the interface in Google's systems. And then recently for memory, somebody's been integrating Mem0 for memory. And I'm sure there's a few others I've not thought about. But we thought, I guess we thought it would be a much bigger trend, and we hope that trend will increase in time. But look, we don't want what happened to us, which is good and bad. A number of examples, they finally moved them out 4 months ago by now, but into their own little repo. But the number of example solutions that were checked into the LangChain mainline was horrible. Wading through all that stuff was just really difficult. If you're using like IntelliSense and an IDE, I don't think we want that to happen where there's just a plethora of half-baked implementations checked in. We would rather focus on having fewer better. But would we argue if somebody that did a half-baked in their own repo? No, of course not. Do it all day long. That's great. You just probably won't find them in the main Eidolon, right? We want the ones that work, that are strong, that are tested, that are.
Now, I guess, what's your goals for the rest of the year and for Eidolon? And if somebody's listening right now, what do you want them to take away as the big thought?
Yeah, I'll start. Ravi, you finish. So we're adding, like in the engineering side, we're adding, like I said, memory. We will be beefing up our examples more so that we show people the art of the possible a little, and really firming up the developer story of making it easier for people to get on board. We've done a lot in the last few months, but easier for people to get on board and get a lot of value out of it quickly. And that's on the engineering side. I'm sure other features will sneak in here and there as research is made. I guess the last thing would be keeping up on research for me, for all of us, is making sure that we understand what's over the horizon. Maybe it won't be this year, but next year, beginning of next year, the next big hot things, and really implementing the things that are of value to people. Ravi, do you want?
Yeah, I'll just add two things. One is to continue to build with the ecosystem. So we're not standalone by ourselves. We're part of a wider ecosystem. And so it's important for us to integrate and demonstrate value to 1+1=3, that type of thing. So we've got a few key ones, and we're not going to pick 10 of them. We're going to pick 3 things that we're doing with some partners, potential partners, I would say. So love to see that come to fruition, just to be able to be part of that ecosystem story. And then we're part of, again, going back to the use cases, the key ones that are deployed in the enterprise. We're in the sprint cycles with a few of them. And we'd love to see that make more progress. And the enterprises are slower than, I think we'd always like everything to be faster in some ways, but we understand that fewer but more specific use case that can be productionalized and the value can be driven and shown is better than large numbers in that sense. So those are 3 things at the top of my mind, and that really validates both the product, the ecosystem, and then going into next year. And of course, we're not raising money right now, but that'll be a key part of our fundraising, which will probably kick off in Q1.
Right.
It's great to have you on. I really appreciated your insights. There are limited opportunities to speak with people who are truly in the depths and knowledgeable about this, but also can break it out so that way people can understand what you're doing. So I want to thank you both for taking the time speaking with me. I certainly learned a lot today, and I'm hoping that the audience did as well.
Thanks, Josh. Let's get a squash game together sometime. Yeah.
I can promise you. I'll be next time in San Francisco.